See, I told you to do that dual MOSFET. Okay, as per that you created on dual MOSFET. Here I wanted to tell you, in case of dual MOSFET has gone, so we need to replace the particular MOSFET only in case of PWM sections. Here current consumption of dual MOSFET and individual MOSFETs will be vary. Please don't try without complete knowledge, okay? Because in dual MOSFET concept we only told him to do those things at the beginning stage, means in VN section, okay? In case if you won't get any dual MOSFET, then I told him to prepare yourself. That is applicable only in VN section, not in PWM section. If you try to do, you will lose your processor or maybe processor IC, okay? So that is one most important thing you have to keep it in your mind. See how nicely you created two types, right? So one is this and other one is this one, right? Very good try, Mr. Param. Like this you have to do in a VN section, okay? This dual MOSFET concept is only used in VN section, okay? VN section, not in PWM section. Okay, understood? You got my point, right? So now one more thing I'll tell you. So the fact is, if dual MOSFET has gone, so you need to replace dual MOSFET only. Two ICs I told you. This RT8171C and RT8175. Okay, these two ICs are same in pin section, but one most important thing is the power good. For this both IC has different power good, okay? One having 3.3 volts and other one having 1.05 volts. This power good will mismatch in this, okay? That is the reason I am telling you, if IC has gone, so you need to replace with the same IC. Don't try with this IC. This one contained high-low MOSFET, but this one is dual MOSFET. You came to know what is the fact in dual MOSFET case. Now you are very curious to know more about VCC core, right? See, one thing I will tell you, for CPU 3 to 5 volts required. In this case, in particular motherboard case, 3 voltage required. One is RAM voltage, 1.35 or 1.5 according to the RAM. Okay, it's a DDR3 or DDR3L or a DDR4, whatever it may be. Second one is PCH volts, it's 1.05, and third one is core voltage. Talking about VCC underscore core. In the motherboard, this is the final coil voltage. So if you are considering only CPU section, this is the final coil voltage. So now I will tell you step by step, one by one. One more important announcement I will tell you. You can do service by seeing any books. or by seeing any videos. But one most important thing is, without your superiors or without your gurus or good guidance, you won't understand this section. You know, there are many generations are there. Generation 1 to generation 13th at present. Okay, each and every generation having different processor and different kind of core section will be there. By seeing in one board, so you can't solve all the motherboard, all generation of motherboard. Okay, in books it will be printed one. Okay, it will be printed means it's, for example, I will tell you VR underscore on, VR on, one signal will be there. If it is printed in a motherboard, but you won't come to know what is the VR on in other motherboards, some other name also will be there. So that is very difficult to understand. That is the reason I am telling. I am not denying to get the mother books and all, but you can get the knowledge, but complete knowledge in practical section only you will get. So that's why I am telling you, you can join any course. So by joining the course or by getting the experience, you will get good knowledge. Okay, complete knowledge. This is basic. This first level you are getting the knowledge. There are many sections are there.
Generation will change.
Once you become pakka, so then you come to know what the course, what it contains. Okay. So now I'm telling about this motherboard. It's LAC 811P. Okay. This is the 4th, 5th generation. Means this is a 5th generation processor. For this processor, so we are having this particular IC, CPU IC. Okay, RT8171C. Okay. So for that, a dual MOSFET also is there. See, we come to know some components are missing. You know why? The core coil was giving 0 impedance. Because of that, we are checking one by one, step by step.
Okay.
From reverse we are checking, from coil section we are checking. Then only we came to know some components are missing here. Now we are discussing about core IC, VCC core. Okay. What is the motherboard? LA.
Hyphen.
Okay.
C811P.
C811P. According to this, I am explaining the core section.
Okay.
Okay. So point number 1, in any core IC, basically we require input voltage. In any IC, it requires input volts. Okay, this is the first point. First we need to check all input voltage. Second most important thing is enable thing. It requires a command. Command in the sense, some other all powers will be good, then this will start work. So the requirement, it's a command, it comes through PCH or some other IO or PCH or this one processor, wherever it may be, but particular command it requires. Input is not sufficient. Input is, it will start working, but for start working, enable is most important thing. Okay. In any IC, input is 100% required. Second one is, according to that enable, this working function will start, otherwise it will keep an idle. Okay, so it won't do any work, so it will be in standby mode. Okay, so next thing is enable, called VR on or some other name. Okay, number 3rd, it will sense CPU is okay to work or not. Okay, it will sense is most important, because first it gets some signals from CPU, then only it will start its work. Understood? So these basic things you have to keep it in your mind. In any IC, these 3 are most important thing. Okay, here one more thing from PCH also some good some voltage will come. Okay, from PCH also some voltage it will get, voltage or signal, whatever it may be, some signal it will get, so then it will start working, then only finally we will get output. Okay, in this case after getting input, enable and sense, then also you are not getting output or it's not triggering, so then in some condition we need to replace the IC and then we need to check. Okay, these are all basic things. So in this particular case we will check the schematic. Okay, so by schematic I will explain you. This is core IC section, this is plus VCC core. Okay, this is a coil PLZ02, PLZ02. Okay, this is a coil, and here see this one is connected to dual MOSFET. Next we come to CPU IC PUZ00. This is the section. Okay, PUZ00. First point I told you, what is that? It's input voltage, VCC. See here, VCC number 1, VCC pin. What is the pin number? 6. Okay, second one PVCC. See here, PVCC
21.
pin number 21. What is the VCC voltage here?
5 volt always.
5 volts always, right?
Yes.
When you plug in charger, so immediately this voltage will get, it means that CPU IC will get ready in idle mode. Okay, V volts always through 20 ohms. Okay, next PVCC pin.
This also 5 volts always.
It is here. Okay, PVCC pin number 21. Okay, this also 5 volts always, 2.2 ohms with caps. Okay, with cap. Next, any input voltage. See here, one more voltage is there, V reference voltage. That also most important voltage, V plus VR EF underscore VCC. This will be 0.6 volts usually. Okay, this one
0.6 volts.
Yeah, this one is connected to pin number 1 and pin number, see, one more VCC is given here, right? Pin number 31. What is that? IMON means current monitoring. This one used for current monitoring purpose. This input 100% we required. Okay, IC requires input voltages to function. So 1, 2, 3 signals, voltages are coming here. Okay, next fourth one, any input voltage. See here, one more 5 volts always is there. That one goes to
30 number.
29 and
Yeah.
30. Actually here voltage divider is there. See, as per the voltage divider it's going to 29.
29.
This is actually ground, right? V boot cell. Next, what is that? V boot cell. V boot cell. See, 5 volts. Pin number 29. Okay, raised, what is that? Voltage divider. Through voltage divider the supply goes to pin number 29.
Yeah.
Okay, next, any input voltages.
Last.
last one.
Down. This one.
See, this one also one kind of voltages, but it's a pull-up voltage. That also we need to check. Pull-up resistor voltage. Okay, what is that? Plus 3 volts
Plus
always.
3 volts always.
This is also most important thing.
Yes.
Okay, so it's a pin number 17, but this is output section.
This is output section.
Yes, we are ready is the output section.
Okay.
But anyway, but register volts we will check
Okay.
because that's input section.
Yes.
Voltage should be there. Okay. Then see VCC pin number 16. This also very important point. Okay. 19 volts goes to town cell pin number 6. Town cell. Okay. Town cell pin number 16. What is that? 19 volts. VCC VB underscore VCC underscore core. This also very important.
Okay. 19 volts.
And any other inputs? 5 volts over. See, this is output thing. Once VCC core comes here, it will sense will be there. Okay, then feedback will goes to IC to produce continuous voltage. So here, any other input? These 5 volts over, right? PVCC 17. Okay, see, these all are inputs. First point. Okay, what are those? One is VCC pin number 6, 5 volts always using 20 ohms. Okay, resistor. Second one is PVCC pin number 21, 5 volts always. This one using that resistor it has come. Next one VR reference 0.6 volts will be there. It's a common one. It's a pin number 31. I1. Next V boot cell. It's a pin number 29. That through voltage divider it's coming. Okay. Next pull up resistor.
3 volts always.
Pull up resistor 3 volts always. The town cell. Okay. Town cell is very important things. 19 volts. This IC is getting. Okay. These all are input section. See, as per this first one input section we are checking, right? This one we are checking. Second one is enable. Let's check enable what it is. Now it's a second point. Second one. Which one? Enable. That time I told you enable is nothing but VR underscore on signal. This is a common name. But in this particular IC, will you check where it is? Search VR on, where it is?
We are on means
Generally, what will happen in core section, enable signal will be VR on. It's a common thing. Don't stick on in only one particular name.
okay.
So you need to research. Okay, many generations are there, many boards will be there. So in each board, the name will be differ. You won't get. If you search 100 times also, you won't get VR on. But if you know the concept, you come to know what it is. Okay, this is enable signal.
Yes.
Right? Enable means you need to check enable. Enable.
Enable. Yes.
So what it is? Enable. VCC enable
VGG.
comes from VGG gate.
Yes, sir.
Okay. See, this one is most important. The name is VGG underscore
We get.
V gate. Important thing. Okay. Very important signal. Without this signal, this particular IC won't work. It will be in idle position. It got input, but it don't have any input, any enable things. Okay. Command. So let us check this VGG V gate from where it has come. So this it is coming from 44 page number. So what is that page number? We will check. We will get. We'll copy. paste, search here. Okay, here it's output where, see, through pull up 1.05 it's coming out, which I see. This is PUG 00 RT8171C. PUG 00. Check in the motherboard. PUG motherboard. PUG 00. That also RT8171C. Okay. See, from this particular IC producing the power good, we are ready. It's nothing but power good. This power good is named as VGG VGate. See, this one is coming from, what is that name? PUG 00. PUG 00. This IC. This one producing PG as VGG VGate. See, this section is VGG core PLG02. Check it here. So which coil it is? Right, this is the PLG02. This is the output. Okay, that VGG core section is there, no? Through this core section, this output coming out. This voltage is 1.05 we are already getting. Okay, from this particular section we are getting power good to the V core section. Okay. So now we come to know VGG gate is coming from this particular IC. Particular coil, means it's a particular coil IC is this one. This also same IC here is used, but we are checking VCC core section. Here we are getting 1.05 volts, but here we are not getting, so we are tracking of VCC core section. Okay, so next we come to know this one V gate is coming from this PUG 00 IC. Next, okay, this input enable is over. Next one, see, as per the instructions, sense. From CPU side some voltages will come. Those things we will check in this particular IC from where it has come. See here, VDIO alert and clock. See, this one is data, clock and alert one signal. Okay, these three are very, very important. This is coming from where? Through the resistor, 1.0 volts always, and it's coming from 1.3 volts always pull up resistors, and that is signal from where? CPU. See that we are SVID date, we are SVID alert, SVID clock. These complete sections coming from processor. See, if processor is ready and this IC also getting enabled, then it will check the signal from processors. See, that processor giving 3 signals to the particular IC. Okay, what are that? Third one, processor signals. Take it out. Okay, processor signals. What are those? Pin number 13. What it is? VDIO. Okay, it's getting 1.05 volts always. It's through pull up it's getting 1.05. See, this one in input section, this one also we note down, because here 1.05 volts always. Okay, this also we have to check whether this voltage is getting or not. Sorry. And here 1.8 volts always also we need to check. Okay, these are our input section. Here one more point I got, 1.8 volts. Okay, always. that pull up resistor we need to
Yes,
check.
yes.
One more we got. See here it's 1.05 volts always. Here 3 resistors are there. So through that resistors, see one more resistor also is there. So through that resistors, it's coming to particular pin. This one will decide what kind of frequency CPU want. This is the most important thing. Please note down. So this is very very important things. What processor voltage it want, that signal, that data and clock it supplies. Pin number 1. Pin, what is that? 14. Alert. See, alert they want in low condition, not high. Voltage won't be there. If voltage is there, it will be 0. It won't work. It will be in idle condition. So clock. This also 1.05. And pin number 15, right? Pin number 15, V clock. This also 1.05 volts from processor. Okay, this is from processor. These 3 important points. Okay, if core IC will get these 3 points, then it start working. Then it produces high gate voltage, low gate voltage, and phase, everything it will generate. And one more thing is driver IC is inbuilt in this. See, in core section we required on driver IC. That in this section it's not there. So it is inbuilt of this IC. Okay, so it has inbuilt. So here from processor it's over. That inbuilt driver also will start working once we get that enable input signal enable and this processor signals. Okay, and then see here this set 1, set 2, set 3 all will start. Okay, according to the processor it will start, and it produces, see, driver enable signal. Driver enable signal 18 and pin number 24 both are same. It's connected, internally connected to each other. See, DRV VCC enable 1 through that 0 ohms resistor it named as DRV VCC enable 2. This one goes to pin number 24. Okay, these both are same. Enable signal, once enable signal starts, then it starts boot, low gate. Okay, drive, what is that, phase. This is the phase, LX phase, low gate and high gate also, upper gate. See, enable we came to know. Here boot cell also we came to know. It's a ground, through that voltage divider that input has come. And here once phase will start, that phase will come to dual MOSFET LX VCC. Then dual MOSFET starts using input output voltage. See, input voltage 19 volts VCC core, it's coming from 19 volts VB. Okay, once dual MOSFET starts, then high low concept will start. Okay, upper MOSFET, lower MOSFET will on and off it will start. It generates some phase. So then it generates the voltage. It comes to the coil. Okay, this is the working principle of CPU core IC. Once again I'll repeat. Okay, note down. First we need to check all input of this particular IC. Okay, the inputs are VCC, PVCC, reference, 5 volts always, 1.8 volts always, 1.05 volts always, and here 19 volts VCC core, 3 volts always, here 5 volts always. Wherever the 5 volts always and 3 volts always, what are the voltage they given, we need to check the particular resistor. Okay, in one side it's getting or not. because those all are pull-up resistors. Once IC starts working, so then using that pull-up voltage, it will start giving the output or input, whatever it may be. See, this VCC, V sum, plus and minus, this also comes from core, that also it sends. Okay, according to this these ends, so it will start phase, boot will produce the amplifier. Okay, it boosts the amplify signal. Okay, next phase, lower gate, upper gate voltage will start directly, and it starts the driver enable signal also internally. Okay, because driver's IC is inbuilt. Okay, this driver enable and driver enable 24 pin and 18 pin both are connected to each other. Next, so it sends, that is the third point which I told you, that sends from processor. 3 voltage will come, I mean 3 signals will come. Okay, one is data, alert and clock. Okay, that goes to data, alert and clock. Okay, these are our most important signals from CPU. And one more thing is there, that is a VR hot, VCC VR hot hash, VCC underscore VR underscore hot hash. You know what is this? Any idea? Hot in the sense heat. Okay, once processor will get more heat, okay, this signal goes to the particular pin, then that processor this IC will stop working by this signal. You know why? This particular temperature will be there. For example, up to 80 degree or 90 degree or 100 degree, whatever it may be, till one particular degree it will work. If it crosses more than that degree, for example, you forget putting the heat sink here, then what processor will do? It generates more heat. Okay, in that case, this may get damaged. To avoid the damage of this processor, this particular signal goes to core IC and it will stop working. Okay, this is the most important thing. Please note down this. Okay, once, I'll repeat, once that particular temperature gets more, it will protecting the CPU, it will shut down. Okay, it won't work, it will disconnect the working. Even input, enable, what are the requirement voltage, everything, if it gets, then also it will stop because of this signal. Okay, pin number we are at on. Here it's a low signal it required, pin number 12. See, hash in the sense high or low. If it is a high, it will work normally. Okay, in case if it is a low, stop. Understood?
Yes, sir.
This top is underline is there. Okay,
Yeah.
Underline in the sense it's low. If it is low, then it will enable. Once it enable, this working function of particular IC will get stopped. That is the reason it should be in high position for normal work. That is the reason here it's 1.8 volts always will be there. Using this pull up, here this particular VR hot having 1.8 voltage always. Okay, so always it will be 1.8 volts should be there. If no voltage, then motherboard will be in dead condition. It will be in dead condition. Clear?
Clear, sir.
Okay. Now once again I'll repeat. In randomly I'll tell you. In case of CPU section, this particular VCC core, if it gets more heat, then this particular pin V boot cell, this will be the reason. So you need to check this particular voltage divider. Okay, it may be because of this resistor faulty, or maybe because of IC faulty. To one particular frequency it will generate. In case frequency is increased, so then this particular coil will get heat. PLZ02. Understood? Sometimes you feel it's a display also you will get, but the thing is you will get more heat on that particular coil. That is the reason. Okay. Now once again it's a final. I will finalize what are the checking points. First we checked this coil here. Impedance was 0.01 like that. Okay. And next when we checked, this particular IC was not there. This is a dual MOSFET. Next, see if it is in dead condition, so we need to check required voltages. One is what are those? One is VCC, PVCC, and all input reference voltage and all input voltages, that pull up resistor voltage or normal voltage, everything we need to check. And turn also very important thing, turn set. Okay. And after that what it gets, all input it will get. Okay. And then section is enable section. Enables coming from one more IC, that's RT8171, same they used, that's the VGG gate. From there its enable signal is generating. Okay. That's coming to input as a input, enable input. See that I told you we are on, it's not coming from IO or some other things, it's coming from one more IC, that VGG core IC. Okay. So here it gets enables, then it starts working, and it senses, access the sensors from CPU. Those are data, clock and alert. What are those? VDIO, alert, VClock. Okay. After this, one more important signal is VR hot. This is the final one. So this also we need to check properly. Here 0 ohms resistor, or maybe it's a direct one. So through 1.8 volts pull up will be there. This section where it goes, that section also you need to check in case if you are not getting output. Okay. These are the function of what? CPU IC working function. Okay. This is the final coil output. Okay, this is the core voltage. It's very important voltage. So that I already explained. I explained only one motherboard. Okay, more than 1000 motherboards core you need to check. By practice you come to know what is the working function of core voltage. Okay. This is a basic motherboard. It's actually mobile processor. Once we get the IC, we check this particular board is working or not. Okay. But using this motherboard, I explained what is the function of vCore IC. Understood? So you need to remember these points. Okay. This is a basic. First time you are hearing those things, so you come to know by experience one by one. Once you do the motherboards, you come to know. Okay. Now we close this section, and once IC comes, then we put the IC and we'll show the final result. Okay. Thank you.